Let's think about this idea of composition of functions. Let's pick two functions here just to serve as examples. How about if we had 2x plus 5 for f, and g, well, maybe g of x is, say, x squared plus 3x minus 1. Well, here's what I would like to do. I would like to pick some number. Now, pick any number you want. Just for example, I'll use 2. It could be any number at all. I'll use 2. Now, what I'm going to do is I'm going to process 2 using, say, the g rule. And that'll bring me over to some output, right? See what I'm doing? I'm taking 2, inputting it into g, so I'll have to compute. We can get something there. And that'll give me some output, right? So I'll get some number here. Now, what I'm going to do is I'm going to take this number here as an output and put it into f. And that will bring me to some other output. All right, so maybe that will take us over here to some other number, and we'll process it with f. So all in all, what I'm doing is I'm starting here with 2. I'll process it with g. That'll give me some number as an output. Then I'm going to take that output, process it again with the f rule. That'll take me to this final output. So let's do it. Let's actually see where it takes us. So I'm going to start here with this number 2, and I'm going to put it into, right, where are we putting it first? I'm going to put it into g. So I take that 2, I put it into g. Now, you got to remember that that collection of symbols is represents an output. We have to work a little bit to get what it is, but we're going to do that in a minute. So that number there is g of 2, right? It's some number, and we'll compute that in just a minute. So then I'm going to take that number, whatever this is, and I'm going to put it into f. So let's put that in. Now I'll use square brackets because too many parentheses. So I'll take that number and put that into f. So we're starting with 2. We're going to put it into g, right? That's g of 2. That sends us to this output. And then I'm going to take that number, g of 2, whatever that turns out to be, and I'll process that with f. That'll take me over to this final output. So let's do this. Let's see what we get. I'm just going to bring this straight down. So this will be f. Now, what is g of 2? Well, we know how to do this, right? What do? You take 2, locate g. Here's g up here, and you replace all the x's with 2. So I'll get 2 squared plus 3 times 2 minus 1. So let's do that. So we'll get 2 squared plus 3 times 2 minus 1. We'll get f of, what do we get here? 4 plus 6, 10, minus 1 is a 9. All right, that turns that to a 9. So here's where we are. We started with this 2 up here, all right, I'm in the circle. Started with the 2, I put it into g. Now I had to do a little bit of work to process it, and that work is right here, right? We squared it, multiplied, subtracted, and we got a 9. So we put in a 2, process it, you get out a 9. So I'll just put a 9 here. And now what we're going to do is we're going to take this 9 and put it into f and see where that lands us. So here it is, right here. Put that 9 into f. So we're going to have, now, put the 9 into f. Where's f? That's all the way up here. What do? Replace that x with a 9. So we'll get 2.9 plus 5. So it'll be 2 times 9 plus 5 is 18 plus 5 is 23. So all in all, where we are is here. We started with a 2, processed it with g, we got a 9. We put the 9 into f, and we ended up over here at 23. Now what I would like is to start with the 2 and just go directly to the 23. Right? Maybe I really don't care about the intermediate value of 9. I just want to know if I put in a 2, all in all at the end, what do I get out? The 23. So I would like to develop a rule that goes from the beginning, non-stop, all the way to the end. And here's how we're going to do that. So I'm going to do this in general. So I'm not going to pick a 2. I'm going to pick any number at all. Maybe, and I'll just call it x. All right, x could be 2, any number that's in the domain here. Now I'm going to take that number, and I want to process it and get out that number right there. So what I'm looking for is, what would I put here? So here's kind of an overview of what we're doing. We started with 2, we put it into g. Now this is small enough I can actually write g. here's g. So on the outside, I'll put the name of the function. On the inside, I'm going to write the function. It's x squared plus 2x minus 1. And then over here we have f. F is that 2x plus 5. So what I would like to get now is this. What's a good name? Okay, well, I'll put the name out here, and then I'll put the function, the actual rule, right in here. So I need a good name. So I think we can name it like this. If you look back up to the top left, how do you read this? Don't you read it as f of? When you get to the parentheses, you read that of, f of, and then you read g of. Right, so look at what we have down here. What is this? This is f of g, and then I process a 2 into it. So I'm going to name this function, not f, not g. I could name it h, right? But this function here is composed of these two functions. So I'm going to just call it f of g. But I'm going to write the of like this. I'm going to write of like this. F circle g. Now that is a circle, and that is an operation, f circle g. So what it means is this. F circle g is going to be the name of a function, and if we apply it to x, it means this. F of g of x. All right, so f circle g is the same as f of g, right? F of g, f of g. So this is the name of one function, g. This is the name of another, f. This is the name of the new composed function, f circle g. Now, let's get this rule. How do we get this rule that takes us nonstop from the beginning all the way to the end? Here's what I want to compute. I want to compute f circle g of x. Okay, right? Apply this rule, whatever it turns out to be, apply this rule to that number. It's like applying this rule to the 2. Applying this rule to the 9. I want to apply this rule to the x. Well, this means, I have a meaning for this, right? This means f of g of x. Okay, that's what this means. F of g of x, right? Just read it. F of g of x. F of g of x. So let's compute. So what do you do here? What is g of x? Now, back over here when we did this long ago, we had g of 2. What do you do with a 2? Well, you put it into x in the g function. But now, we have an x. So if you put x into g, you get g of x. You just get exactly g of x, right? What is g of x? Well, g of x is right here. So let's write that. So this is going to be f of x squared plus 3x minus 1. And then what do you do with this x squared plus 3x minus 1? Well, you put that into f. So you go over to f and you replace all the x's with that x squared plus 3x minus 1. And that's going to look like this. This will be 2 times. Now that x, I'm going to replace this with x squared plus 3x minus 1. And then, don't forget out here, you got that plus 5. So plus 5. Let's multiply through. We'll get 2x squared plus 6x minus 2 plus 5. I can combine those. So I will get 2x squared plus 6x plus 3. So I'm going to name this rule now like this. F circle g of x, all right, so we have an f function. The f function is the 2x plus 5 up here at the top left. The g function is this trinomial, this quadratic, x squared plus 3x minus 1. And the composition of both functions, f circle g, okay, f circle g is this trinomial right here. Our nonstop rule is 2x squared plus 6x plus 3. Now let's test it. What we're saying is that this rule right here should take us from the beginning, skip the mediate, all the way nonstop to the end. So we know what we're supposed to get if we use a 2, right? A 2 went to a 9, a 9 went to a 23. So all in all, 2 goes to 23. Let's see if we can get there directly. So I'm going to compute this. F circle g of 2, which means we'll get 2 times 2 squared plus 6 times 2 plus 3, right? I'm just putting the 2 right back into my new rule. So what do we get here? 2 times 2 squared is 4 times 2 is 8, plus 12 plus 3. Sure enough, we get 23. So that's our discussion of composition of functions, and I'll just write kind of what we said all in all. If you have two functions, f circle g of x, that means f of g of x.